Today we're looking at an IBM Unix workstation from 1996, this RS 6000 43P Model 140. We'll tear it down to clean it up and have a look inside, figure out if it's healthy enough to get an operating system on, and then we'll fire up the big gear. Some IBM P5 series enterprise servers from the early to mid 2000s, which are actually the successor to the RS 6000 line of the workstation we're looking at today. We'll use that P5 gear to attempt something called RIPL booting, remote initial program load, to turn this thing into a diskless workstation over the network. It probably won't work, but the enjoyment is in the journey, so let's get into it.
Hi, and welcome to the RISC Systems 6000 family. I'm
Collab Retro.
And I'm
Also Collab Retro.
In the next few minutes, we will introduce you to the basics of setting up and operating your new RISC Systems 6000 power station or power server. It's an impressive addition to your office.
This is an IBM RS 6000 Unix workstation from 1996. This particular unit is a 43P Model 140. The RS 6000 line came out in 1990 and was entirely meant for business use, either individual workstations like this 140. The IBM marketing material states it is an ideal workgroup server for running small business and departmental applications, but it could also handle some 2D work as well. They released a variety of these RS 6000 machines into the very early 2000s, and the model numbers can be a lot to wrap your head around. This unit on the desk is basically the lowest end model available, at least as of the documentation you're looking at here from the year 2000. But the RS 6000 line ran the gamut from individual Unix workstations, some hybrid server grade units that could still sit at a desk, all the way into full-blown servers. Speaking of model numbers, if we slide this door over, we can see this identifier tag down here. And it says it's a 7043. 7043 is like the family or type of machine. IBM would give them other numbers like this one. So in a lot of the documentation, the marketing name would be the 43P Model 140, just like it says on the badge here. But the technical documentation might call this a 7043 Model 140. It can be kind of confusing. Oh, and I've got the LED bad edition. Very desirable. Very sought after, which is actually kind of a bummer because when you start these things up, they actually report status codes about their very slow boot up process, how far they are into it, and if they encounter any errors. So I'm hoping like a cable's just unplugged, or maybe this just works. We're going to tear this thing down and see if we can't fix that, hopefully. Now, it'd be an hour-long video talking about the history of the RS 6000 line, but I like to hunt these things down. I actually have its big brother, the F40. Because in the 2000s, the RS 6000 line eventually became what IBM called, for a brief period, their pSeries line. And I've got some pSeries gear. Over in what I'm calling my retro rack, there's a couple massive mid-2000s pSeries enterprise servers, the successor to this humble workstation we've got on the bench today. And these things aren't just typical old x86 machines. The RS in RS 6000 stands for RISC system, because they have processors using the RISC architecture. This one in particular is sporting a 166 megahertz PowerPC. You might recognize the PowerPC from fan favorites such as the Sony PS3. Well, sort of. It's got some PowerPC stuff going on in there. And a lot of Apple computers. I don't know if this thing works, so the plan for now is to get it looking a little better. It looks like this skunk is going to come off. I've poked my head in here once, and I have a pretty good feeling that I know what this stuff is. Yeah, we'll be able to get that off, no problem. It's got this lock right here, which is locked at the moment, and usually I wouldn't be opposed to, deleting that just to make my life better. But there are no screws on this case. On the back, I'll show you. So I think this lock is actually supposed to hold the top metal case on the chassis. And so I'll need to hunt down a key. It's pretty simple. I was looking at the documentation and I tried a couple keys I have that kind of look like that. There's only like a few tumblers or whatever you'd call it in here. I was messing around a little bit. I don't know how to pick locks. My guess is if you wanted to learn how to pick locks, this would be a pretty good candidate for your first try, but I don't know how interested I am in that. Let's get this lid off. It just slides right up. Very simple. And then in the back, we can see this foam that is deteriorating. I highly suspect that is the dirt that's all over this thing. You can see I can just make permanent impressions with my finger there. That was for airflow reasons. I might rip it off if this keeps causing me a problem, but fine for now. Let's get this case out of here. View on this side, we've got a couple fans in the front here, the main board, which is going to be totally bespoke to this machine, I suspect. These are PCI and ISA slots, so that part's pretty nice. But it's particular, you can't just throw any old video card in here if you want to do video stuff. I have a video card on the way that we're going to try out. I think these are just ECC DIMM RAM sticks, and I'm looking down here. I have two 64 megabyte sticks here, 128 megs, that's plenty for 1996. On the back, we've got the power supply fan, obviously power in, some sort of locking mechanism, maybe, not sure what that's about. PCI and ISA slots on the right there, of course. A couple serial ports. Notice I don't have a video card, so you can interact with this machine over the serial port. I think that's how you'd typically do that if it wasn't hosting applications for you and you're directly interfacing with it. So we're gonna have to do that initially at first. I can't remember the name of this, but you can plug in like Wacom tablet, I think, like pen tool type stuff for doing like CAD, since these were like Unix workstations where you'd be doing CAD type stuff and all that professional stuff. And yeah, you can see it's got that special icon there. You'd almost certainly be plugging interesting peripherals in there. Over here, we have what I suspect is a PS2 mouse and keyboard, printer parallel port, 10 base T Ethernet on board. That's pretty cool. So that's 10 megabit Ethernet connection right there. SCSI, probably Ultra SCSI 2 or something like that. And then this always cracks me up about these workstations. Line in and out for speakers, microphone, and headphone jack. And then the star of the show, showing its age here. This is an AUI port, attachment unit interface, for 10 base 5 Ethernet. It looks like a game port. That's for network. And you can use a MAU, media attachment unit, to pop that in there. Ooh. Now this is interesting. This is a 210T from Centercom, twisted pair transceiver MAU, media attachment unit. But as you can see, because of these fins here, it doesn't fit. They made one called the 210TS. I think the S stood for slim. And you can see, I was gonna show you that it fit in there, but it doesn't. This is how you lock them in to these little pins. Well, guess we won't be using that. It kind of fits. Yikes. Well, so much for that dream. I wasn't going to use it anyway. We've got the 10 base 2, I guess, for historical record. Sometimes you do need these thinner ones. You can see it's got this edge here that lets it slide in a little deeper. In this case, it's no good, but these are really cool too. Like totally metal, awesome little units. I guess I should say what they do. It converts that AUI over to twisted pair Ethernet cable that you can plug in and put on your more modern gear. Over here, we've got the power supply from Delta, another fan, got the floppy drive, just probably a 1.44 megabyte floppy. Yep, I see it right there. And then we've got the CD-ROM drive, and it looks like it's SCSI. We've got a SCSI cable coming up to an adapter to the larger SCSI size there. This stuff's all pretty dirty, so I'm gonna start taking things apart, and we'll pull it out so that we can see the processor in there and get a closer look at everything. It does kind of look like there's probably a procedure you're supposed to follow, but I kind of just like winging it at first, and I'm sure there is very detailed, it's not going to work, very detailed IBM documentation about how to do this properly. It's sort of funny. I got this on eBay, and the guy had several of them. I want to say upwards of 8 maybe, and a bunch of us in the serial port Discord, someone posted the link. We snatched them up like right away, and so the guy was probably like, why did all my RS 6043P sell within 24 hours? Hopefully it works. I think it was sold as working. That would be nice. I just undid this thing. That appears to have been the right choice. That was easy. Down in there, more of that horrific foam that is getting everywhere. That would have been sucked right into that fan. So that would have been nice. This looks like another network interface card that I forgot to point out. They don't give you a lot of room to get in here. There's like this big plastic clip thing whose purpose is not immediately obvious to me, or how to get it out. Someone really torqued this screw down. Oh my gosh. You can get in there pretty easy with a longer screwdriver. I'm sure this comes out, but it seems sort of integral to the back of the case, and I don't really want to deal with it. So we got that. I should have done that before taking this plate off, because it is keeping this riser in place, so I gotta be careful with that. This is an IBM branded network card of some type. My bet is on fast Ethernet. We've got a PCNet fast AMD chip here. Got the floppy drive out, and I'm trying to sort of figure out what's going on this setup because I'd like to get a little further. I want to see if hopefully the LED assembly is just unplugged. And I can't quite tell if there's a hard drive in here. I'm almost positive there isn't. Let's see, this is just a fan holder. Look at all that metal just to hold that fan. Wow. Flipping around, I need to get to these screws for the CD-ROM, so I'm gonna pull this PCI riser board out carefully. It is plugged in at the moment, so that's fine. As you can see, a little different looking than your typical computer. We've got SCSI, what looks to be SCSI here, another SCSI connector maybe, a big one, and all the different input, output, serial ports, the peripherals and stuff plugging into special connectors on the board. Got a clock battery. I suppose we'll pull that. I don't know what this is. This might be the CPU, but I thought this would be the CPU with the fan. Let's see what this thing is. That is 512K of L2 cache for the CPU, which was apparently a separate upgradable part, or maybe you upgraded to a better CPU and you needed more cache or wanted more cache. But anyway, that's what that is. Got the CD-ROM out. It looks a lot worse than it is. Everything's pretty tight and compact, but really not that hard to get apart. I haven't read any documentation or anything like that. Of course, no hard drive, just more of this heinous foam. So I'm gonna blow all this off, and I guess I'll show you the CD-ROM. Seeing IBM branded mundane parts like a CD-ROM, I mean, IBM didn't make this, someone made it for them. But I don't know, there's always something exciting about that, because in my head, IBM is just such a big deal. Manufactured October 1996 for IBM. Nice little SCSI drive there. Got that adapter for the two different sizes. Pulled the clock battery out, and I don't think it's good anymore, guys. I don't think I've ever seen a cell battery like that corrode. A little bit of a corrosion issue down in there. Not too bad though. I don't think it got onto any chips. I'm gonna have a closer look and mitigate that real quick. Clean that up. I think we caught that just in time. It hadn't spread to any surrounding pins or anything. Of course, the real test would be pulling the board out, but I think we got it. We're okay. It's a CR 2032, and I was looking through my stash and starting to panic, but I have exactly one. And I have a pretty good feeling that this thing doesn't like to do much without its clock battery, or it's going to complain a lot if I know anything about IBM. So I'm going to pop this in there. And then right in here, I'm almost certain this is the ribbon cable that goes to that LED indicator panel I was showing you on the front there. And it looks like it's in here. Nice and snug. Looks like it's never been touched since the day the people at the factory put it in there. So I'm going to leave it for now. It might just work rather than risk any damage or further damage to this cable. So I'm going to get everything buttoned back up. I got a bunch of the gunk blown out, so it's pretty clean in there now. I'll do everything I just showed you in reverse order, and then we'll try to fire this thing up. Taking a closer look at this retaining bracket for the riser board, and it's also a hard drive bay, which is pretty nice. It's back in here. It's kind of got some slots it wants to be in. Yeah, there we go. Just like that. Got everything back together. It does not seem like it, but it's a lot cleaner inside. No dust floating around anymore. Deleted this thing, little modification, because I think it's stupid. And it was going to be in the way. I've got the SCSI cable hanging out here in case we need to get a hard drive on this thing. I don't even know if I have a hard drive for this, but I think I've got some adapters. I'm going to do a little work on the front of this case. And somewhere along the way I touched something I shouldn't have. I have no idea what this blue stuff is. It's not from the battery. So I'm going to clean this up and I'll be right back. By no means perfect, but certainly a lot better looking than it was. And there's my proof. So the deal here is obviously we'll give it some power. This plug is not on yet. And then we need to get on the serial console to another machine. And I'm almost positive, pile of adapters here. I'm almost positive I'll need a null modem cable to accomplish this successfully. So we'll wire this up. Here we go. I'm going to give it power. I don't think it'll do anything. Just kidding. It's starting. Oh, is that the... Something is unhappy. We have a CD-ROM. One of these fans is very unhappy. I'm going to look around a little bit. And yeah, our LED is definitely bad. I can see the light indicator on the power. That's too bad. Of course, I'm not filming, and it made a chime, which means it's probably somewhat healthy. So the firmware on these things is pretty sophisticated. I think it's open boot firmware, whatever that's called. Yeah, it just made a little chime. Definitely a dead LED. I'm getting nothing on the serial console, so I'm going to mess around with having a null modem or not. So far, kind of good, I think. What we're looking at here is me getting so excited that the serial console came to life that I forgot to turn my microphone on, and I think it's trying to network boot. Yeah, it was trying to network boot because it couldn't find a hard drive. That's what this boot P thing and the S, it's basically the attempts as that count was going up. It was 9, I think, the last time we were looking at it. And then we've got this error code. I guess we can look that up. Yeah, I think that error code just means there's no keyboard because I didn't plug one in. And now it's just trying to boot again over the network. S equals 1, I think that's its attempt 1, and it'll just keep counting up. Let's power it off, get a keyboard on there, and then I think we can pound the 1 key to get into the SMS menu, which is the firmware menu that will let us kind of poke around at this thing. One of these fans is not well. Hopefully not the CPU fan. Okay, it's off. Let's get a keyboard on there. Got a keyboard on there, and I'm just going to start pounding the 1 key as I boot it up. I'll also try to capture that chime noise it makes. It might be F1, I can't really remember. Let's see. We are in. I think this thing is healthy, and it's still trying to boot P. I don't know how to escape into the SMS menu, but I think that's fine. I mean, yeah, I'm feeling pretty good about this. I think I have a video card we can throw in this thing, and we'll see what happens. So far, this is really good. The fact that it's trying to net boot, and we can see the firmware kind of splash screen over the console, that is good. This is a GXT 250p video card. They made a bunch of different video cards for these things, and they're pretty particular. There's like a matrix of compatibility, and the slot they're in matters. This one should work. I was reading, you're supposed to pop this guy in slot 1, PCI slot 1, which is this bottom one here. I was kind of complaining about these screws all being tight, but I think it's just because they're so small. It's hard to kind of torque them or whatever. Okay, video card in my 1996 Unix workstation. Very exciting. Get this puppy in there. Got keyboard and mouse, monitor hooked up. Let's turn this thing on, pointing at the screen. It doesn't do anything for quite a while on the monitor or the serial port. That's why it's nice to have that LED indicator on the front. Monitor's coming to life. Oh yeah, look at that, RS 6000. It's complaining about some code. Yes, video card works. This is awesome. I have the serial console hooked up as well, and you can kind of take over, basically, if you press 0 on the serial connection. And it's trying to boot. I think I need to restart it and catch that fast enough. And here we are in the System Management Services, SMS, and I got here by pressing 1 and F1 repeatedly, so I don't know which one it was. But you can see we can move around, take a look at the configuration of the machine. This is the machine's BIOS, essentially. It knows about all its memories. It knows about that GXT 250p. It's got a firmware from 2002. That's interesting. And it also knows about that fast Ethernet PCI adapter. So then we can go utilities. You can change SCSI IDs. And what else can we do here? Boot. So here I can choose the boot options. And yeah, it is giving up on the floppy drive and the SCSI CD-ROM because there's nothing in there. And trying to boot out over the network. You may have noticed over in utilities, we got something called RIPL. This stands for Remote Initial Program Load. Oh, we have a mouse too, by the way. So you can do all this with the mouse. Aside from a fan that needs imminent replacement, this thing is super healthy. That is really exciting. With this thing working, we are about to embark upon a journey. In the IBM world, there's something called Initial Program Load, or IPL. It's IBM's fancy way of saying booting an operating system on these machines. More specifically, it's actually from the mainframe days where you would copy the operating system into the mainframe's main memory. That was called an Initial Program Load. As you may have noticed, I don't have a hard drive to store an operating system on for this thing. We're going to attempt something called RIPL, or Remote initial program load. So RIPL just being a fancy way of saying we're going to net boot this thing to get an operating system running on it. I don't know if it's actually called RIPL. I imagine it is. I'm going to call it RIPL, so let me know in the comments if that's the case. What we're going to attempt to do here is set this up as a diskless workstation that RIPL boots, that remote initial program loads over the network, aka net booting. Pixie boot is the popular option people use these days, but I was surprised to learn this RIPL thing had been around forever. I had first learned about it when researching it for some IBM PS2 gear, which I'd like to try in the future over Token Ring. These RISC machines run AIX, IBM's Unix variants, so we're going to need to set up another AIX machine as a Network Installation Management Master, or NIM Master. And of course, the machines we're going to set up as the NIM Masters are the IBM P5 gear I've got sitting in the retro rack. I am not joking when I tell you the acronyms are going to start flowing after this point. We're going to RIPL boot a BOS, that stands for Base Operating System, by the way. In our case, it's going to be AIX onto this RS 6000 from the IBM P5 machines set up as NIM Masters. At that point, we should have a diskless workstation that can boot over the network with RIPL. You with me so far? I don't even know if this is going to work. I haven't tried it yet as of the recording of this segment. I haven't even shown you the P5 gear. We're going to learn a lot more acronyms and how those are all wired up. Let's go have a look at them and get started. These are a pair of System P5 Power Machines enterprise servers from the early mid-2000s. I think this one's a P52A. This one is a 550Q. The Q stands for quad. It has two quad-core Power 5 Plus processors in it for a total of 8 cores. It's what IBM would call an 8-way machine. This is just a little 2-way machine. I like to call this one the small one and this one the big one. The big one is like over 100 pounds. It's ridiculous to move. This one is a little more manageable. It's not the full length of the rack. And I love these things. They're super interesting. The FAA here in the United States used them for many years. I'm sure they're probably partially still in use. You can actually find documents online how they're phasing out to, x86 Linux-based machines to run all that away from this P5 gear. And as I was saying earlier, these are the successors to that RS6000 we were looking in there. Well, the RS6000 line. These are pretty beefy enterprise servers for their day, and there's a lot to learn here about how they all connect up together. This IBM server up here is operating as what's called an HMC, or Hardware Management Console. There are special modules on these for remote management. They are configured to talk to this guy. I can manage, power on, power off, install operating systems, fully control both of these machines through the UI this thing is hosting. We will be doing that. As you can see, I don't have rail kits for them, so I've just got some generic shelf rails for the bottom one and everything is stacked. If we move up a little bit, you see I've got this IBM hub floating around. The HMC network is its own little world at the moment. We'll go over that. For any of that to make sense, I think I'm really going to need to pull one of these onto the workbench and have a look at the back and try to explain how this is all connected up. So I'm going to move these out of the way and lug this over to the other room, and we'll be back. Here's the small one on the bench here. And as I was lugging it over here, it's quite a bit heavier than I remembered. At least 85 pounds, and it's heavier than that because it's got some hard drives in it. On the front, it's got the operator panel, and it also displays basic startup codes as it's progressing. They're more important for these machines because a lot more can go wrong than the 43P we've been messing with. But you can see the lineage. It's still the same basic idea. You can get in here and kind of configure certain aspects of it, but I've already done all that. I'll show you that when we look at the hardware management console. Speaking of which, we've got this special card on the back, and you can see it's got a couple of Ethernet ports labeled HMC1 and 2. This is the FSP, the Flexible Service Processor. It's the remote management card for this pSeries gear, so if you're familiar with more modern stuff like Dell's iDRAC or whatever, it's the same basic idea, except these are pretty sophisticated. You can cluster these machines together under the control of one HMC, which is that 1U server in the other room I was showing you. So this card actually comes out. I think we'll pop the lid off and I'll show that to you shortly, just because we can. It's integrated into the main board of the larger P5 that's in there. But both of them have a cord coming off of this into that hub I was showing you with the red wires, and they're hooked up to the HMC. So that's why I wanted to pull this back here and show you, kind of give you a physical view of what's going on the back and why they're all networked up to the HMC like that. This pSeries gear is pretty interesting. I don't quite know how to describe it accurately, but The machine itself is basically like a hypervisor. At the hardware level, it's kind of the whole bread and butter of this stuff. So a hypervisor is something that can run multiple VMs, virtual machines, so run other operating systems. And IBM lets you divide these machines into what are called LPARs, logical partitions. I told you, the acronyms, they're not going to stop. So basically, you can divide this machine up to run multiple VMs, but I'm going to call them LPARs in this video. So I can have like 2 AIX LPARs running on this thing, and we dedicate one of the network interfaces to each LPAR, and that's actually how we're going to RIPL boot. So when I'm saying I'm booting over the network, it's going to be the network coming off of these actual network interfaces that are connected to our AIX VMs running on these guys. And the HMC, the remote management, is like a totally different network that we aren't going to have to worry about too much in this video. We'll be getting these on the RetroRacks network. That thing in there is hosting a 10.0 network. We'll get the LPARs connected there, and one of them will be set up as our NIM server, basically the master server that we're going to be able to net boot from. Hopefully all of this is tracking so far. Let's take a look at this service processor. I haven't been in this one in a long time, so this is pretty exciting for me. It is right here, and it pops out just like this. This is a replaceable part. Here's that flexible service processor board, the remote management board. I want to say it's also running like a lower grade power PC chip or RISC chip. Don't quote me on that though. And I think there's like jumpers around here somewhere that let you reset it. Oh yeah, they're super tiny. At least on this model of board, these little jumpers, there's a procedure for resetting the password and everything right there. So there's a brief overview to get you familiar with this P5 equipment. The other one is just bigger and more powerful. It's very similar. Obviously looks identical on the front. I'm gonna go get this stuff all hooked back up so that we can power on everything and get into HMC. It's quite the operation to plug everything in and power it on in the right sequence that I've found works the most reliably. You feel like you're starting up a 747 or something. I'm gonna throw all this back in there and I'll bring you along for the boot up sequence, and then I'll show you my ridiculous way I KVM into that HMC. Okay, got everything stacked back up and we're ready to power things up. Let me walk you through the game plan. This guy is already on. He's happy with life. That is the HMC network. One of those network cables is plugged into this guy, hosting the HMC network. The other two are going into the service processors, that card I was showing you on these guys. So that's all good. However, I don't have a way to interact with this UI. It will host it over the web, but I don't have a computer that's on that network in the other room, and I don't want one. I want that to be totally isolated. So for now, on the other side of this wall, past the rack, are some stairs. And under there is a KVM. And that's gonna let me remotely access this guy. It's got a PS2 mouse and keyboard and VGA coming off into the workshop, which I'll show you. The link from the KVM is coming over here into one of these guys, an SIP module. It converts an Ethernet cable, well, I guess it's probably not Ethernet, a Cat6 cable over to PS2 and VGA. I'm gonna plug this in to the back of this, and that's how we're gonna interact with this thing initially. There's other ways to do that. I could bring a monitor in here, but that wouldn't be nearly as funny or fun. At the top of the rack is a bunch of networking gear. This is hosting the RetroRack network, as I call it. It's a 10.0.0 network. I have plenty of computers on this network. That HMC has 2 network interfaces on the back. The red wire is going into the hub for the HMC network local to the machines, and we're going to configure that blue wire. It's coming up into this switch as a machine on this network. I've got plenty of machines in the other room, and then we'll be able to use the HMC over the UI, but first we'll have to do that all over the KVM. I'm going to stop talking. Let's power this stuff up. There we go. We need this end up for a functional network here. Okay, so I've got this plugged in. It has power. It's not on. Check this out. The light path diagnostics panel tells you what's wrong, if anything's wrong with the machine. You can see it's complaining that one of its power supplies isn't plugged in. IBM's always doing the coolest little things. I need to find something to power this on. Ironically, unexpectedly, these 1U machines are way louder than even these two, because something to do with the smaller fans, you know, sucking more air in faster or whatever. Anyway, this one's an absolute screamer, unfortunately. So it's already pretty loud in here. It's about to get way untenable. So let's power this on, and then we'll go look at the HMC UI. I'll explain all that, and then we'll talk through how and when we power the big guys up. So I need a little, there we go. There she goes. Here's that machine starting up. The HMC is actually just running on some lockdown Linux distro, and IBM customized it, and it looks at like some hardware identifiers to make sure it thinks it's allowed to run on that particular machine. So that machine in there is actually special. It's meant to be an HMC. The software looks for that exact machine. There's a variety of them. I think these days people just run it in VMs though. While that's starting up, here's my setup. The keyboard can only get to here because the cable's not long enough to get to the KVM. That KVM I was showing you is on the other side of this wall. Here's my mouse. Okay, the HMC in all its glory. Did I mention it's really slow? It takes like 15 minutes for it to fully boot and pop up what I assume is a web browser with some Java stuff. Lots of Java going on. This thing here is Dell R510. It's actually from the KVM. If I hit the control key 3 times, or maybe just twice, I don't know. You can rename those. So that little module I was showing you, it actually stores the name. So let's call this one HMC. So yeah, now it says HMC. Let's say you know what computer you're looking at. I only have one on the KVM. Let's log on and launch the Hardware Management Console web application. Okay, that blur was ridiculous. I'm refilming this to show you what I was doing. So in Systems Management, we've got servers. And this is where you have the list of servers that the HMC has under its management control. You can see it's seen 2 of them before. They're on this 192.168.1 network. That's the network that's operating on that hub. They're in their own little world together, and that's fine. What I need to do is get the second network interface of the HMC machine on the RetroRack network. So if we go over to HMC Management, that's how you manage the machine itself. You can go to Change Network Settings, and in here, LAN adapters, you can configure the IP of each interface. The first one is going to say on the 192.168.1, that's the HMC management network, and I've configured the second one to be on the RetroRack. Let's go see if that's going to work. This machine I'm on here has access to the RetroRack, so I can ping the RetroRack's router, presumably. Yes, I can. Well, let's try to ping the HMC that we just gave this address. And we can. So the HMC is accessible from the RetroRack network. This is some primo home labbing. This is pretty fun. We're going to get this Windows XP VM booted up. It also has access to the RetroRack network. And of course, it's an older operating system running some old version of Java. Got an old version of Internet Explorer. Maybe the HMC likes Firefox more, I can't remember. We're going to interact with the HMC the same way we did locally. That was just a web browser running on the actual Linux machine. We're going to do that here, hopefully in this Windows XP VM. First check, see if this thing can talk to that. And it can. That's exciting. The real moment of truth here. Can we access the web UI? I think it's just on port 80. We'll see. I might have to refresh my memory on that. It wanted HTTPS. And we're going to have to get around a bunch of expired certs. Here we go. That's the UI we saw. Oh yeah. You can do it. Oh man. Always allow. HSC root. Pop-up blocked. Always allow pop-ups. Yes. You can do it. Oh yeah. That's not loading up. Oh my god. It's not loading up everything. It won't show this frame. I've done this before. I can't remember how I got it working. Firefox is the answer. What version of Firefox is this? 3.03 from 2008. Perfect. So this thing opens a pop-up, which of course browsers don't like, so you got to get that whole thing going. It's obviously a JSP app of, Java app of some type. So let's get into systems management. And yeah, everything is loading now, so that's good. Now we can interact with the HMC like this, a little more ergonomic, as fun as the KVM is. Let's go give those machines power, and their service processors will start up, and this thing will be able to see them. So they'll connect for a little while, and then hopefully this thing will see them. This is this boot up sequence I'm talking about. You get the HMC on, then you get the service processors on, and after that, in here, we can actually tell the machines to boot up, and we'll mess with their LPARs, and we'll probably need some cold ones to get through this NIM stuff, but let's go turn those machines on. Hello. I'll try to keep this brief. It's very loud in here. I'm going to plug the little P5 in, and we should see some action on the front there as the service processor comes to life. I can hear the power supply fan, and that's looking good. It is going to report some status codes, and you can like actually Google them, and it'll tell you exactly what step in its boot sequence it's at. Now, the service processor has power, and obviously the front display does, but the machine is not up. It's not powered on. Its CPU isn't running. This is just status from the service processor, and we can see there on the right, that is the FSP, the light blinking there, coming to life and trying to go find its HMC. I think the HMC is on the left. Doesn't really matter because there's just two and there's two lights, so you get the point. The big guy is a slightly different hurdle. It wants 240 volts, which I installed right here specifically for that machine. So you can see the big yellow thicker gauge Romex there. So this is a 240 volt outlet. This cord is going to the back of the big guy. So let's plug him in, get his service processor cooking. Such a beautiful sight, those two green displays. I love the look of these machines. And now on the hub we can see all three network interfaces are up and trying to do something. Let's go look back at the HMC. Back at the HMC, and this part can take a while. This guy is the smaller one. I know that simply because I see 52A in the machine name. This thing knows it's powered off. Fully connected to the HMC, we can control this thing now. The bigger one, because I plugged it in after the other one, it's not up yet. It's got this firmware not ready thing. It's just going to keep cycling and trying to connect to the HMC, or maybe the HMC tries to connect to it. I'm not entirely sure. Either way, it's still going through its like little baby boot sequence before we can power it on. Well, let's take a look at a server and see what that looks like. Here you can see I've got a couple LPARs. I have divided this thing into two LPARs. I was getting ahead of myself. So now it knows about both servers. This JDE one is the original host name that the original owner had. It stands for JD Edwards. Real enterprisey stuff there, if you're familiar. So we can select this one and do tasks, operations, and we can power on the little one. And it makes you confirm a bunch of things. And now it's going to go through its boot up sequence. And this reference code thing over here is actually what's being displayed on the front green panel. In the HMC, it's pretty cool. You can just click on the reference code and it's got all the documentation baked in. And so it's saying this particular reference code means starting standby power on transition file. So it's going to roll through a bunch of these codes. I'll be back in a little bit. The little guy is powered up, and again, we've got the status. You can click on a status and the HMC has all the documentation to tell you exactly what everything means, which is actually pretty nice. And now we can go in to the little server, and you can see I've got two LPARs in here, like I was saying. This first LPAR basically has everything. This other one doesn't work. So it's got two processing units, 4-ish gigs of RAM, and if we click the reference code, it's saying waiting for virtual terminal to be opened on the HMC, meaning I think this thing has booted into AIX. You can think of these little LPAR divisions, logical partitions, as VMs. And I think we can get in here and go to tasks. There's some way to get a console window. Yeah, open terminal window. And then of course we have to accept a bunch of cert mismatch stuff. And we have a null pointer exception. I can't remember if I've ever successfully opened a terminal window here. That would be obnoxious. But not to worry, physical KVM to the rescue here, I think. So let's do that same thing, try to get into the terminal window. I think it does the same thing where it kind of complains about something. Yeah, on the HMC itself, it does not like the certificate. And we got to do a hostname mismatch, okay? And there we go. This is AIX running on that machine. Well, that's not, is that entirely true? This is the SMS. Remember that other one, the system management services we were looking at on the RS6000, which is theoretically the point of this video, but here we are with the P5 stuff. I think we can just exit this. I'm gonna press X. I'm sure I'm gonna press 1, and it will try to boot into AIX. I love the IBM splash screen stuff. Yeah, there it goes. Now it's trying to boot into AIX. This particular LPAR, this instance of AIX, is not happy for some reason. It continually gets into like this diagnostic mode that I don't really understand. I'll let it boot up. Yeah, see, I end up in this diagnostic operating instructions thing. I'm gonna press enter, and then I'm gonna just do the default, which is the routines, and the system's gonna continue to try to come up, and maybe the AIX experts can tell me what's wrong with my install here. I basically always get this. I can get into like single user mode. Anyway, we're not gonna use this LPAR. We're gonna boot the big guy up. and we'll use him for the NIM server. So I get to this system verification thing, and then I want it to test everything, and it says F7 to commit. And you can hear me pressing F7, and nothing happens. So I can't get past this step. Anyway, that's enough of this. This is AIX running on an LPAR, by the way. It's time to power on the big dog. That thing is scary. Power on. Okay. Same idea. It's gonna, you see the reference codes, same as before. It's gonna do its boot on sequence, and I can hear it when it starts up. So right now, it's not actually running, like it hasn't ripped up the fans, and it's doing like some preliminary steps, and eventually I'll hear it kind of kick up in there. I'll be back. These things take a long time to come up, and they just have like the wildest codes. This one is hypervisor data structures are being transferred to system storage. It doesn't get any more enterprisey than that. The big dog's up. It's in standby mode, meaning none of its LPARs are actually running, but it's powered up, so we can go take a look at it. I had previously divided these into two LPARs, CLABPAR 1 and CLABPAR 2. I mean, come on. And you can do really weird stuff. I gave one of the LPARs 2.5 processors. I think you can go down to like the quarter processor or something. Pretty interesting. Each LPAR has 8 gigs. I think I installed AIX on these things, and you can see they say not activated. That just means they're not on. IBM's always got to have a funny phrase for everything. So you can do operations activate the profile. I'm going to turn on LPAR 2 simply because it's got more processing units. And you can see it says activating partition. This just means starting a VM, basically. And it's got reference codes as well. It's almost too much information. Waiting for power on of slots to complete. It's like, I don't really want to know how the sausage is made. You know what I'm saying? What's this one? Waiting for vterm. Okay, this one's ready. Let's go back to the KVM. Same deal. We're gonna open up a console window here. And it is also on the SMS menu. You can configure these to boot right away, but usually I don't like to do that because I'm always kind of messing around. So we can just exit out of this one again. And there we go. I think this one, hopefully, I haven't booted up in a while, will successfully boot into AIX, and we won't have all that diagnostic stuff. And you can see the HMC is super aware of everything going on. The reference code is AIX is starting. It knows AIX is like installed on this thing. Running AIX 6.1. Hopefully that's good enough for our NIM adventure here. And yeah, this is Unix, a Unix variant. There you go. Did another boneheaded maneuver where everything I was filming was super blurry. So I'll show you what I did. You do ifconfig A, and you can see one of the assigned physical resources is at 10.0041. And I can ping the retro rack, which is great. Excellent. But the whole point of doing this is to be able to SSH into this machine so I don't have to film this screen and mess everything up. And as you can see, apparently AIX 6.1 does not ship with an open SSH or any SSH server, which I find ridiculous. You know, IBM stuff. We're having fun. We're having a good time. IBM still hosts all the packages I'm going to need, I think. So I'm going to attempt to somehow get them on that machine. I'm not sure how I'm going to do that, and I'll get it installed, and hopefully the next time you see me, we will be SSHing into that server. I have exciting news. I was bitching over in the serial port Discord about why doesn't AIX come with an SSH server, and Juniper suggested that I try RSH. RSH stands for Remote Shell. It's basically an unsecured SSH. I think that's a good way to think about it. You wouldn't want to do this in real life, but I'm down here in my basement. These things aren't even on the internet. So this is a totally viable option. The AIX machine has RSH, and we'll come over to good old Putty here, and the trick is setting our login. That's the IP of my LPAR, and check this out. We're getting asked for a username, and we're in. So huge thanks to Juniper. That just saved me hours, probably. And you get access to the serial port Discord in my $5 and up Patreon, by the way. So yeah, I'm in here. It's NIM time. I've been doing a lot of reading, and I would love to tell you at this point that this would be a detailed video about how to set up NIM, but I haven't actually done it yet. And it's involved. I've been like reading tons of documentation over the last week. I'm like, sitting in bed, laying in bed with my wife, and she looks over and she's like, what are you so mad about? I was like, I'm not mad. I'm just reading another 300-page PDF about how to set up a NIM server on my P5 machines. Remember, we're doing diskless, and there's a really good guide on the IBM website, kind of a quick start how to do NIM thing by a certain Storm M. Harris, who worked at IBM, still does, I don't know. And they basically say that diskless clients have been phased out. So, and essentially say, don't do this. So anyway, I'm going to do it. My point being that it's going to be involved. It's going to take a lot of trial and error. I will post, like a text file of all the commands I run when it works. But I hate to say it, I'm just going to dive in. I'm going to, you know what I mean? So it's going to be faster and easier for me to just do it and figure it out. And then I'll bring you along when anything interesting happens. I'm going to get to work. I'm going to power down the little one because I'm not using it right now. But I'm going to give you a brief taste of what it's like in here with no noise canceling. It's not terrible, but imagine a data center or, someone's network closet with like 4 of these racks racked up, just full of those things. The literal other rack of stuff running is not exactly helping. So the next morning, Saturday morning, got a fresh cup of coffee, my lucky mug. I drink like a pot of black coffee each day, every day for like the last 15 years. Crippling caffeine addiction. It's just so good though. So here's the status. I was messing around trying to get the HMC as a NIM server, about 2 or 3 hours, and I made some progress. And then I kicked off a really long running task where it's taking AIX 5.1 install media and making it so that it can host that as a NIM host. It was taking forever, so I just left everything on. We are gonna find out together if that succeeded. I'm guessing we're gonna see an error message in the upper left there. Let's see. Whoa. It says command OK. I think maybe it worked. We can do NIM LS. LS NIM. Oh yeah, look at this. This stuff here, I think, is my AIX 5.1 install media. So here's the deal. I was doing some reading, and I think the newest version of AIX this thing can run is 5.1. And the oldest version of AIX that my LPAR can serve as a NIM host is 5.1. So like the Venn diagram, we're in the middle, luckily. It's not the end of the world. If I need an older AIX version and an LPAR, I can just do that, but it takes forever. So I'm just trying to use the AIX 6.1 LPAR I've got here. So we have the AIX resources, but we need to configure this thing to understand that we have a diskless client. There's a little more work involved to bring you along for that. I don't actually know if it's going to work. We're going to do SMIDI NIM make Mac, of course. Oh yeah. This interface you're going to be seeing is SMIT, the System Management Interface Tool. Absolute classic on the IBM AIX stuff. Let's just call that thing 43P. We have to give it a host name. And enter. What's this? Do I care about that? Oh boy. Token ring. Token ring RIPL. ATM RIPL. That's crazy. I'm going to say this is an Ethernet network. Oh, geez. Machine type. Diskless. Okay, yeah. That's important. I'll go find out which hardware type this is. See what I mean? This is a little bit involved. We're going to go with RS6K for that one. I don't know what I'm doing. I'm going to fill this out. I'll be back. Right, we're getting somewhere. It's complaining when I try to set up that diskless client that it can't resolve 43P to an IP address, because of course it doesn't exist. So I need to put it in probably the Etsy host file, manually assign that. I have this 43P resource. There's a bunch of more acronyms about what all these things are called, which I don't want to wrap my head around, and I'm not qualified to explain it anyway. But basically, this 43P resource is a diskless machine ready for a NIM operation, I guess, which means we're ready to make our first RIPL attempt. Let me power this guy on. I was confused about F1 and 0 before to get it to stop and hop into the SMS menu. When it's graphical like this on the VGA, it's F1 on the local keyboard. On the console, it's the 1 key. So there you go. That fan sounded okay for a second. Now it's utilities, RIPL. Let's ping the RIPL server. How about that? How do I change this? Integrated. Okay, this is useful. Remember, we have that 100 megabit card. We're going to want the fast Ethernet card for sure. Pinging what? I didn't set anything. Oh, look at that. Now it's letting me do it. That's weird. after I changed the adapter. 10.00, what did I set this thing to? The RIPL server is 41, and we have a gateway there. Okay. Oh, one second. Okay, I think it's gonna try a ping this time. It says everything's cool. Okay. So I saved all those settings about the RIPL NIM server and everything. I think it's just gonna try now? I don't know. Not good. Got the boot P and its attempts, which I believe means it's failing. Oh no. You see, this is what I was afraid of. You know, you follow some instructions, everything seems okay, and then you get no indication of errors or anything. And you just kind of like, it's a black box. I'm gonna turn the camera off again and start messing around and looking around, see what I can find. Those resources I was showing you earlier, I don't think they were for diskless clients. So I'm regenerating them for diskless use, I think. And we're 41 minutes in so far. It's a very long debugging turnaround time, as you can imagine. So I'm gonna let this finish and keep plugging away. Holy crap, it's doing it. I read more documentation, configured a bunch of different resources. It is TFTP booting its settings. 43p is the name of the client on the NIM server. Unfortunately, I'm pretty sure it's not gonna work. I couldn't create all the resources I think are required. Mismatch with the AIX 6.1 or something. I don't know. Look at that. Uh-oh. Default catch code dead beef. That's not good. Come on. We were so close. I have like a console. We'll go look this up. Okay, I messed around with some stuff. I don't want to talk about it. Trying again. Dead beef, though. What a classic. I think that's like an error code probably in this thing's firmware. Like I was saying, I couldn't allocate something called a dumps. Same problem. Dang it. A dumps folder for this thing where it's going to dump all of its error logs. I'll go look up this code and see if there's error logs on the NIM server. I haven't found any yet. It uses TFTP to get files from the NIM server. I'm on the NIM server doing a TCP dump of the TFTP protocol, and you can see that thing came in and tried to get, maybe send us this file, and that's all that happens. It's in that error mode now. Here's what's in TFTP boot, and it's looking at that thing. That's a binary. Shouldn't have done that. One issue for sure, I don't think it's what we're hitting, but we were going to hit it eventually, is you need to create these resources on the machine that the remote computer can use. So like a root file system, a swap place for swap, and then this dumps thing. I think this is an AIX folder location for like crash logs and error dumps and things like that. I can make everything except this dumps one. Let me show you. So I'm going to run that command. And it takes a moment to error out on me. It says, cannot find information in the predefined device configuration. Something about TMSW, node, and driver. This might just be because I'm using some older instructions to try to do this on AIX 6.1. I'm not sure. This is a blocker. I can't figure out how to do anything about this. And if we do ls/nim again, you can see I've made all sorts of resources. I've got this diskless version of my OS, essentially. I've got the diskless 43p. I've got a root resource for it, where I think that's where the files actually live on the NIM Master that it can netboot off of. And then we've got a paging location for swap files. So I don't know. It's been several hours. I can't figure it out. I always just get the code equals dead beef, which is probably just a joke from the developers that they don't actually know what the code is. That's why it says default catch. It's just catching an error and doesn't have any useful information for me about it. I hate to do this, but this is going to have to be a two-parter. It's going to be hours and hours and hours of troubleshooting this, and there's a lot of avenues to explore. I actually got a lot further, to be honest with you, than I thought I was. It was pretty cool to see the 43p actually attempt to talk to the NIM server. Now, a bunch of problems here. I'm using AIX 6.1 to try to load 5.1 onto a pretty old machine. What I probably ought to do is get like AIX 4.3-ish or something, which would have been a little more error appropriate for this 43p. We'll get an LPAR with that. We'll have the NIM server be exactly the same version of AIX as the client we're trying to diskless boot, and I'll be a little more thorough about how I'm setting it up. So I'll bring you along for that journey eventually. I think basically I'm happy that this RS 6000 is healthy. If I was to throw a hard drive in there, I bet I'd have no problem. Maybe we'll get a blue SCSI on it someday or something like that. At any rate, I hope you enjoyed following along and learning about the P5 series of stuff, a little bit of AIX stuff. AIX is super weird if you're coming from just Linux. It's like a It's a whole nother world, basically. I love firing up this P5 gear and messing around with the HMC. It's probably my favorite, enterprise computing gear I own. I love the whole ecosystem. So I know it seemed like I was complaining, but it was really fun to actually do this. And there's going to be more in my future because I would really like to get the diskless boot working. But again, thank you for making it this far into the video. And if you haven't already, please consider subscribing. Helps the channel grow. And I also have a Patreon. I post behind the scenes type videos, what I'm tinkering with, that sort of thing. As always, thank you for watching, and I'll see you in the next video.